Hello, today we're going to be solving systems of equations. We're going to be using substitution, elimination, and graphing. To solve a system of equations, well, first of all, a system of equations is more than one equation put together, and you're looking for the point or points that make all of the equations true. So we're first going to look at substitution. When we do substitution, we're going to look for a variable that we can kind of nicely-ish get by itself. So to me, this top equation, I can get y by itself a little bit more nicely than x because I'd have more fractions. So I'm going to move the 15x to the other side. I get negative 3y equals negative 15x plus 12. To get y by itself, I divide by negative 3, and I get y equals 5x minus 4. So what I'm going to do is I'm going to take the other equation, and since y equals 5x minus 4, I'm going to plug 5x minus 4 in for y. So I'm going to get 7x plus 5 times 5x minus 4 equals 28. And you'll notice we have now gotten rid of the y's, and we have an equation of only x's, and we can solve that equation. So we get 7x plus 25x minus 20 equals 28. So 32x equals 48. We divide by 32, and we get x equals 3/2 when we reduce that. To solve for y, we're going to take x and we're going to substitute it back into either equation. So you do 7 times 3/2 plus 5y equals 28. And you solve for y, and you're going to get y equals 7/2. You could plug it into the bottom equation, you could plug it into the top equation, it doesn't really matter. Once you get that, you're going to write your point as your solution, so x comma y, so 3/2 comma 7/2. Now we're going to solve a system using elimination. So the goal with elimination is to get one variable completely eliminated by multiplying by numbers that help it eliminate. So looking at this, I'm going to take a look at my x and my y, or my x's rather. I'm going to try to eliminate x's. 8 and 12, they both go into 24 nicely. So what I'm going to do is I'm going to multiply by different numbers to get them to equal 24. So my top equation, I have to multiply by 3. My bottom equation, I have to multiply by 2 to get both of the x's to be 24. Now, I do need one of those to be negative in order for the x's to actually eliminate. So I'm going to multiply by a negative 3 on the top. So I get negative 24x plus 15y equals 18. The bottom equation, when I multiply it, I get 24x plus 12y equals 0. When I combine these, the x's cancel out. I get 27y equals 18. I divide by 27 and I reduce my fraction, so y is 2/3. I'm going to plug y into either equation. 12x plus 6 times 2/3 equals 0. So when I multiply this, I get 12/3. So this is really saying 12x plus 4 equals 0. And I continue to solve for x, and I get x equals negative 1/3. So I write my final answer as a coordinate point, negative 1/3, comma 2/3. Another method that you can use to solve systems of equations is with graphing. So with each of these, we want to be able to graph it, so we're going to get it into slope-intercept form. So we're going to go ahead and get y by itself. We get y equals negative 2/5 x minus 2. So we're going to go down 2 on our y-axis and put a point. We're going to go down 2, right 5, or up 2 and left 5. And this is what that first graph would look like. We're going to do the same thing in the next one. We're going to get y by itself. Oops, sorry, that's a y. So we get y equals negative 2x plus 6. So we're going to go up to 6 on our y-axis. Our slope is negative 2. So we're going to go down to right 1. And the solution here is where these two graphs overlap. Because that point works, it satisfies both equations. So in this case, it is going to be 5, -4. So graphing doesn't work as nicely if it wasn't a nice point where they overlapped. You'd have to solve it using a different method. Sometimes you're going to get no solution and infinitely many solutions. So this is if you are solving it and you are using substitution or elimination and all of your variables cancel out. It's either going to be no solution if you get something like 0 equals some number or a false statement. You would say that there is no solution. You would get infinitely many solutions if you have 0 equals 0 or something like 2 equals 2. If you get a true statement, when all of your variables cancel out, that's going to be infinitely many solutions. With graphing, it is no solution if you have parallel lines because they never intersect. You're going to have infinitely many solutions if it is the same line that you have to graph twice because every point on the line satisfies both equations. And with systems of equations, you're going to have application problems. So we have Grace and Joe at the candy store. We have Grace here. She bought 5 pieces of fudge and 3 pieces of bubble gum for a total of $5.70. Joe's story is he bought 2 pieces of fudge and 10 pieces of bubble gum for $3.60. We want to know how much it is for 4 pieces of fudge and 9 pieces of bubble gum. So this one kind of naturally has 2 equations to set up. Both of them deal with the price for fudge and the price of bubble gum. If you're ever questioning what to name your variables, reread the very last question, what you're being asked to find, and that could help you figure out what your variables are. So Grace's equations is going to be 5 pieces of fudge at some unknown cost, and 3 bubble gums is $5.70 in total, whereas Joe's would be 2x plus 10y equals $3.60 in total. You can pick any variable to eliminate. I'm going to eliminate my x's by multiplying my top equation by -2 and my bottom equation by 5. So I get -10x minus 6y equals -11.4, and positive 10x plus 50y equals 18. So when I combine them, the x's cancel out. I get 44y equals 6.6. So y equals 0.15. I plug y into my equation and I solve for x, and I get x to be 1.05. So depending on what they're asking you, you can answer a variety of questions here. They can ask for the price of fudge or the price of bubble gum, but this one is specifically asking how much would 4 pieces of fudge, which now cost $1.05 each, and 9 pieces of bubble gum that are 15 cents each, how much would that cost? So 4 pieces of fudge and 9 bubble gums costs a total of $5.55. So thank you very much for listening. I hope this helped.